Okay, so we're going to go ahead and talk about the six trig functions. Now, so far, we've talked about sine, cosine, and tangent, but there's also three others: cosecant, secant, and cotangent. So we already know that sine is opposite over hypotenuse. Well, cosecant is just that flipped upside down, hypotenuse over opposite. We already know cosine is adjacent over hypotenuse, and secant is just that flipped upside down, hypotenuse over adjacent. Finally, we have tangent, which is opposite over adjacent. Flip that upside down, you get adjacent over opposite, and that's our cotangent. So notice that these three new ones, so cosecant, secant, and cotangent, are the original three flipped upside down. One trick I use to remember which is which: sine begins with an S, cosecant begins with a C. Switch that letter. Cosine begins with C, secant begins with S, so I'm switching that letter. So basically I say when I get the new one, the other kind, so the cosecant and secant, they pair up with the one that does not start with the same letter. So sine, cosecant, cosine, secant. Or use whatever other trick you want to use. But again, all we're doing is flipping them upside down. So in this question down here, they want us to evaluate for the six trig functions. Now, I should mention that there's a new symbol here that maybe you don't recognize. So this symbol here and that one there, they are all the same, and it's called theta. Let me go ahead and label this one right here. So this symbol here, it is pronounced theta. It is a Greek letter, so theta, and it represents an angle measure. Can be in degrees or radians. For right now, we're only talking about degrees. So they want us to find the six trig functions. Now, to do that, we're going to have to find the hypotenuse, because so far, I've been given tangent of theta. That's the one thing we know so far. I currently know that tangent of theta is 12 over 5. So let me start by actually labeling what I've been given. Based on this theta, I know that this here is the adjacent. I know this is the opposite, and this over here is the hypotenuse. But I do want to find that value. And to find it, we're going to go back and use Pythagorean theorem. So Pythagorean theorem, that is a squared plus b squared equals c squared. So I'm going to do 5 squared plus 12 squared equals c squared. 5 squared is 25. 12 squared is 144. When I add those together right here, I'm going to get out 169 equals c squared. And as we already know, to undo a square, we've got to take the square root. Take the square root of both sides. Now, normally, when we take the square root, we would use a plus or minus symbol. However, take a look at our picture. If I used minus, I'd be saying that the length is a negative amount, and distance can't be negative. It has to be a positive value. So we're only considering the positive version of this. In our case, this means that c equals 13. So the hypotenuse is 13. Now, there was a shortcut for this one. If you remember learning Pythagorean triples, maybe in geometry, maybe before, you might simply recognize that you have a 5, 12, 13 triangle. It's a special type. But if you didn't, don't worry about it. You can always use Pythagorean theorem. Let me go down and label that. Again, what I did right here, that is Pythagorean theorem. So the same formula you've been seeing since middle school. Okay, so I now have all three sides. It's time to go ahead and plug them in to those six trig functions. Slide this up here. So I'm going to start this time by doing sine of theta. Remember, sine is opposite over hypotenuse. Opposite over hypotenuse, that's 12 over 13. Let's go ahead and do cosecant right now. Cosecant of theta. Remember, that one is sine flipped upside down. So just 13 over 12. Let's go ahead and do cosine. Cosine of theta, adjacent over hypotenuse, 5 over 13. Let's now look at secant. Secant of theta, flip this upside down. 13 over 5. And lastly, tangent of theta. Now this is the one we actually started with. Remember, they started by giving us these two numbers here. So we started by knowing that tangent of theta was 12 over 5. Therefore, cotangent of theta, just flip that upside down, 5 over 12. And that symbol theta is just basically an oval with a bar in the middle, generally angled upwards a little bit. But anything of that shape tells you that it's the angle we're looking for. So here is one full example of a triangle. I'm going to go ahead and do another one. Okay, so here's going to be our next triangle. Put it up right up here. So again, this stuff works for right triangles. This is 7, here's 4, let that be theta. So let's say I'm starting with that. I'm going to go ahead and label what I have so far. 7 is my hypotenuse. Let me go ahead and lock this paper in here. There we go. 7 is my hypotenuse. 4 is my opposite. I need to find my adjacent. Okay, so I'm going to use Pythagorean theorem again. It's going to look like this. I'm going to have, and now let's call this side x. So I'm going to have x squared plus 4 squared, 4 squared equals 7 squared. So a squared plus b squared equals c squared. You can use an a or b here if you like. It doesn't matter. So I'm going to do x squared plus 16 equals 49. And again, my job right now is just to solve for x. You've been already doing these steps when you were solving quadratics. I'm going to go ahead and subtract 16 to the other side. So x squared equals 33. And as before, we're going to go ahead and take the square root of both sides. And again, normally we'd use plus or minus, but this is distance and I can't have a negative distance. So my x is just the square root of 33. Now we do want to check, can 33 be broken down farther? Well, 33 is 3 times 11. Nothing can come out. So that is the value of this side right here. This is square root of 33. And now we're ready to go ahead and actually evaluate those 6 trig functions. So let's start with sine. Sine of theta, opposite over hypotenuse, 4/7. Let's go ahead and take a look at cosecant. Cosecant theta says take the sine, flip it upside down, 7 over 4. Let's do cosine of theta. Adjacent over hypotenuse, root 33 over 7. Now when I do secant of theta, I am going to flip it upside down. So I'll have 7 over root 33, but I do want to rationalize it. I'm going to go ahead and do that right now. Let me go ahead and zoom in a little bit more. Okay, so remember to rationalize, we're going to multiply top and bottom by whatever that radical is in the bottom. So multiply top and bottom by the square root of 33. Okay, so what I have now on the top is 7 root 33 all over 33. That is the value of secant theta. Let's go ahead and do tangent. So tangent of theta. Remember we have opposite over adjacent, so 4 over root 33. We're going to repeat the same process we just did right here. We have to rationalize. So multiply top and bottom by the square root of 33. When you do that, we have 4 root 33 all over 33. And again, notice that 7 and 33 have nothing in common. 4 and 33 have nothing in common. Come over here. Let's do cotangent of theta. Take this final, actually, use this one up here. Take this first one and flip it upside down. Root 33 over 4. So remember, tangent is opposite over adjacent. Cotangent is adjacent over opposite. Root 33 over 4. So this one got a little bit messy. Let me go ahead and block off each answer. Sine, cosecant, cosine, secant, tangent, cotangent. So those are our 6 trig functions.